Okay, this is my attempt at some RevMan basics. So when you go into the RevMan program, you will see this screen. I usually just close and then I go up here if I want to start a uh, new file. So then it asks you for some wizard stuff here. I go next. We're working on an interventional review. So then I go next. You can type in your intervention. So, you know, you can put glycemic index. If that's the diet that you're assessing. And then health problem, I'm just going to put, say, metabolism. We're looking at metabolism during exercise. So I'm just going to put metabolism in here. And then I go next. I know I'll go full review. And then I can go finish. And now to enter my data, there's a lot of options here to enter you can see to enter all the descriptions of your review. But to get the meta-analysis going, I just like to go straight to studies and references on this tab. So I click on studies and references, and then that will allow you to add your references. So you go to this screen here. I'm going to scroll down here and go to let's see how you do this here. Oh, here we go. Sorry, it's data and analysis you click on. And then you can go to let's see how you can go to references, references to studies. You go to included studies, and then you go to add study, and this is where you could add all your studies that you're going to include in your meta-analysis. So you click on the add study, you'll be presented with this thing to fill in the study ID, and here's where you fill in the author and the year. So I'm just going to fill in Smith here, and then 2010. And then you can go next, published data, whatever, next. It automatically fills in the year for you. If you've put Smith 2010, it automatically picks that up. So now just go next. I just scroll through these next. Now what do you want to do? You can either say nothing, and then if you do say nothing, you can go back and add more studies. But in this case, I'm going to add another study to this same section. So then I go continue, and then it asks me for the next study. So I'm going to enter, say, Jones, and go 2013. And go next, next. And then this case, I'm going to say nothing and just finish. And now if I did want to go back, I could just go to, I guess, studies and references, or, and find that tab again. You can see the included studies here. I've got the Jones, I've got the Smith. Now I can still add studies here. So I'm going to add another study. Let's say Kim 2015. So let's say I'll add those 3 studies for now, and I'll go finish. So now I've got these included studies, Jones, Kim, and Smith. Now what I can do is I can go to data analysis, and I can start entering the data for that meta-analysis using those 3 studies. So You go to data analysis, you go add comparison. It's going to be, in our case, it's low versus high glycemic index. So I'm just going to put low versus high here. And then see what happens next. Add an outcome. So we do want to add outcomes, but we can do that. I'm going to just say finish here. So now we've got this comparison over here. And you can come back and you can, the reason I exited it there is I wanted to show you that you can just click on data analysis and it'll show you your comparison that you're making, low versus high. And I can add an outcome. So now this is where I can add the variables that I want to assess. So, you know, in this case, we're say looking at fat oxidation between the two conditions, between high and low glycemic index diets. Here I would go, I'd click on continuous. It's a continuous variable that you're entering for our purposes. And then you hit next. It'll ask you the name of the outcome. So in this case, I said it was fat oxidation. And then you can label your groups here. So let's say your experimental is your low GI. Your control is going to be high GI. And then I'm going to go next. Now this is the type of model that you pick, fixed effects or random effects. Fixed effects is more liberal, so it's going to more likely give you a significant effect. Random effects is more conservative. You know, the type of model you choose, it's a little bit complicated, but you can go with either. Let's go with fixed effects for our review here. You can go with mean difference or standardized mean difference down here. You would go with mean difference if all the if the variable you're measuring has the same units across all your studies that you're including. So for fat oxidation, it's pretty much grams per minute or grams per hour. When you're choosing, you would choose mean difference for that because all the units are the same across your studies. Standardized mean difference is chosen if your units across studies are different. For example, if we're looking at exercise performance, you know, some might look at time to exhaustion. Some might look at a time trial where you're completing a certain distance and an aerobic event in a certain time. So they're all going to have different measures for performance. In that case, you'd pick standardized mean difference. And when you enter your data, it's going to convert it to a standard deviation score and standardize to make all the scores kind of equal across the studies or, you know, equal units. So you pick standardized mean difference if your units across studies are different. You pick mean difference if your units are the same. And I'm going to stop this and continue with part 2.